Hi guys, it's Mr. Yaksik here. We're starting fractions, the dreaded fractions, and one of the most important things to know before we actually get into fractions is how to identify factors and multiples of numbers. So today I'm just going to do a quick lesson on how to identify the factors of numbers and determining whether numbers are either prime or composite. So what I do with the students is I have them at least try for factors 1 through 9 to see if these will be factors of our number. So up here we have 66. And we always start with the 1 because 1 is a factor of every single number. The factor pair that goes with 1 would be 1 times 66. Okay, and now we have to get into knowing some, I call them the golden rules that makes your progress through this much, much faster. So 2, the golden rule for 2 is it's a factor of any number that's even. So the kids will automatically know 66 is even, 2 is a factor for it. And then you just have to figure out, well, what's doubled to get 66? 2 and 33 would be the factor partners for that. For 3, this is a really important golden rule that a lot of students have trouble memorizing, but if they get it down, it will save them so much time. For 3, the golden rule is if you take your numbers, digits, and add them together, if that is a multiple of 3, it will work. So for example, 66, we're going to do 6 plus 6, we're going to get 12. Now 12 is a multiple of 3, so 3 will work. So now the kids would know, and they'd have to figure out, well, what is the factor partner for 3? And that would be 3 times 22. Okay, we go down to 4. Will 4 work? Well, 4's golden rule is if 2's factor partner is even, 4 will be a factor for it too. If you look, it's 2 and 33. So 4, we just cross off our list. It won't work because 33 is odd. 5, this is a golden rule that most of the kids know. 5 is a factor of any number that ends in a 5 or a 0. Well, 66 does not end in a 5 or a 0, so 5 cannot work. 6, that golden rule is if 2 is a factor and 3 is a factor, 6 will be a factor for this number. So 6 is going to work, and then the kids would hopefully, that's a basic fact, would know 6 times 11 would be the factors for 66. 7, not really a golden rule for 7. You just kind of have to know your facts for 7, and we know that 7 can land on 63 and then 70, so it is not a factor of 66. 8 also will not go into 66. If 4 cannot be a factor, 8 will not be a factor. And then 9 is another one we just kind of have to know. 9 will get us close to 66, but not on it. So I have them just go all the way up to 9. So now 66 will have 1, 2, 3, 4 factor pairs. Now what's important about this is that is known as a composite number. And a composite number is any number that has more than one factor pair, more than this first one, 1 and itself. Over here we have 59. So we're going to go through the golden rules. The first one, of course, is 1 and 59. That will work. Now 2, the golden rule, remember, is it has to be even. Is 59 even? No, it's not. So we can cross out 2. And what is good about this is now that we've crossed out 2, we know that it can't have any even factors. So we can get rid of 4, 6, and 8. So now we get to 3. Well, 5 plus 9, that's our golden rule for 3. You add those digits. 5 plus 9 equals 14. Is 14 a multiple of 3? No. And once we rule 3 out, this is why that 3 is so important. No other multiples of 3 will work either. So we can get rid of 6, it's already gone, and 9. Golden rule for 5, it has to end in a 0 or a 5. 59 doesn't, so we can get rid of 5. 7, like I said, it's just you're going to have to know your basic facts. 7 will not land on 59 if you list its multiples, so that will not work either. And once we get to 9, I tell them it's pretty much almost always a safe bet that you're pretty much found all the factors. So this only has one factor pair, 1 in 59, and that would be a prime number. This is going to help when we start finding equivalent fractions and trying to add fractions and things like that. All right, I hope this helped.